Hi, I'm Sean Gannon, and this is Minute Math, and we have a fun problem here. Some friends of mine have a child who is very curious and thinks about numbers, and they came up with this question. He noticed that you take an even number times 6, and that gives you the same last digit of that even number. So, for example, if we took, even number 2 times 6, that gives us a 12. 12 has the same last digit as a 2. And so we started questioning this and started, testing out multiple values of this, and it kept on working. So of course we started thinking, can we prove this? So we actually can, and we're gonna go do that right now. So how do we begin to think about how to prove this? Induction is always a great starting point when proving things in mathematics, but really what tricked me here was the last digit. And it took me a little bit to think about it because I haven't done proofs in a while. And I started thinking and realized that, I really just have to find the same modular arithmetic with 10. The same number, 2 mod 10, is the same thing as 12 mod 10. And so I'm gonna use that as part of my proof here. And with that, our basic form here is gonna have some number 6 times an even number, which is gonna be 2 times some value of n. So let's go find our base case here. Let's let n equal to 1. What happens? Well, we have 6 times a 2 times a 1 here, and that's going to be equivalent to, 12 mod 10, which is equivalent to 2 mod 10. Have the same last digit right there. So let's go make an assumption. I'm going to use my notes here because I don't have this memorized. Suppose we have a 6 times a 2n here, and that's equivalent, or that's equal to, in a way, that's 12n. So we can see it here, and that's equivalent to a 2n, mod 10. So we're gonna suppose this is true. We're gonna see what happens in the next case, and we can show that it brings back to our first case. So then, we need to show that a 6 times a 2 times an n plus 1 for the next n value after whatever we chose n to be, the same thing actually happens. That this is equivalent to 2n plus 1 in our mod 10. So let's go write this out. We have 6 times 2 times n plus 1. Let's multiply the 2 across. So I'm gonna kind of break this out here, do some math work on the side. It's not like a true mathematical paper proof here. Don't hurt me. 6 times a 2n plus a 2 right there. Multiply 6 times 2n, that's a good old 12n, plus 6 times 2 is a 12. Now, what about 12n? We know that 12n, we were supposing here, is equal to a 2n mod 10, or equivalent to, right? Just the 12n. The 12 is equivalent to, which we kind of showed in the first case, a 2 mod 10. Now, with that being said, we can apply both together, and we've kind of seen it. So we can combine the two together, and we can say a 12n plus a 12 is equivalent to a 2n plus 2 mod 10, meaning, going back to the beginning here, that 6 times a 2n is going to be equal to a 2n mod 10, and pretty much there. So what have we shown here? We've shown that 6 times an even number shares the same value in mod 10 of that even number, meaning 6 times any even number gives you the same last digit of that even number. Hope this helped you here, and if it did, make sure you give me a thumbs up and, like this video, subscribe to our YouTube channel. If there's another way that you found a way to prove this, or you found a flaw in my proof, please let me know down in the comment section below. I always like to learn new ways to do this stuff. So, anyway, as always, thanks for watching.